Hi, Anders here from Perciv AI. Welcome to our headquarters. What we are working on is how to use not LiDARs, but radars to make similar kind of perception that LiDARs can do. To do this, we have our own test vehicle with which we collect data, but also demonstrate what we can do. So we will take you for a ride today. But before we do that, we will walk around and see what kind of sensors we have currently on. It's a work in progress in the sense that sensors come and go. We test new ones, we deploy, we send it to the customer. So the current setup, we have 2 radars in the front. As you can see, just like cameras and LiDARs, radars come in multiple sizes. We will talk about that a bit more inside. This is a small one meant for corner applications, so it can hide very nicely on the corner of the cars. Has limited number of antennas. Antennas is in what we measure the resolution of radars, a bit like pixels for cameras or line of scans for LiDARs. This is a big one meant for front applications, which means that this in the near future will be somewhere here behind the logo, meant for L2, L2++ kind of applications. Probably it's too big for now to be on the corners.
So why is it bigger?
More antennas are inside. The more antennas you have, the bigger space you need.
How big is an antenna exactly?
To give you an idea, radars come in chips, and a chip has multiple antennas. This has a single chip with 3x4, 3 transmitters, 4 receivers on it. So it's this big chip. I will show a real one inside. And these big ones are usually cascaded or multiple of those chips. So the same chip, but 4 times next to each other.
Wow.
Thus you need more space. Imagine like 2 cameras on top of each other to extend what you can do. So for now, in this demo ride, we will show you perception with the big boy to see what's possible, what we can reach. But other than that, we have a lot of other sensors on the car. On the top, we have the tower. In the middle, we call it, is our annotation setup. So basically we use it for reference. The top, this is a GPS system from a Swiss company called Fixed Position. It has GNSS, RTK, and even visual odometry all fused together. So we have very accurate reference odometry system. Below it, we have a camera setup. It's an oak stereo camera for now. We use it for radar plus camera fusion, but also just to visualize our results, It's much easier to show it on a camera image. And below it, currently we have one long-range LiDAR here from Hesai. This is also for highway referencing system. And we have a close-range LiDAR from Oster. And of course, there's an elephant in the room. On the other side is yet another radar. It's the biggest we have, at least in automotive sense. It's even more antennas than the one that you see down there. This is potentially the future of L3 driving, when you can just cruise on the highway and leave it to the radars. Yeah. Beyond that, we have a nice waterproof system for the Dutch weather to do the networking and power management, so we can easily add and remove sensors. This whole rail system allows us to do 360, so we can add cameras that look to the left and right, not just to the front. And inside, you will see multiple screens, and then in those screens, you will see the actual perception output as we drive.
So what is the range of a radar?
Well, it depends on the radar itself, but it goes. We have radars which are like up to 2 meters, and we have radars which are up to 600 meters. So it's really up to
100.
Yeah. So just like, a camera could be a microscope and could be a telescope, it's what you use it for. But to give you some ideas, these are useful up to 50 centimeters. They can see farther, but what you can actually do something with it is 70 meters. This can see up to 200 meters. I would say useful between 100 and 120, where we can actually track objects and can say that that's pedestrian, that's a car.
Okay. So the last time we met, you showed me a trunk and there were like tons of computing inside. Is it still the case? Like, can we see?
Yeah, we can see the trunk. But to be honest, thanks to Max and other colleagues, we cleaned it up a bit, so it's not that exciting anymore. So we came from the other car.
Wow, okay, so that changed.
It's much cleaner and leaner now. We have a battery system, so we can quickly charge when we go to big data recording campaigns. We can charge at random stations. We have an open case PC, so we can quickly replace parts if we need to. We have a big GPU there for visualization and processing. Overall end goal is, of course, not to have this in your car, but a much smaller one that we discussed in the office, the NVIDIA setup.
Where do you store all the data you record? You must have some kind of...
We have a big... so we have redundant SSD backup here, and we park in the garage, plug in the car, and it goes automatically to our servers.
Okay, I'm used to LiDARs like recording like heavy bags. Is it still the case with radars as well, or is it different?
So radars are lighter, usually, because simply they have less points inside the recording, but we do record everything. Okay. So we also have the same problem, like every LiDAR company, plus the radars. But we can also discuss low-level radar data, which is not point cloud, but a bit earlier, and that's very dense and very hard to store.
Okay.
Cool. So let's get inside.